This is part 2 of a series of videos. To watch part 1, see the description.
So, one further very fascinating part of physics is astronomy, so the physics of space, the physics of the stars and of planets. And there are many intriguing things going on in the universe. There are black holes, there are neutron stars, there are magnetars, there are pulsars, and so on. And I want to talk about a few of these. So, if a star dies, so if there aren't any atoms anymore to fuse, if a star dies, then it can become several things. If a star dies, gravity wins and the star collapses into itself. And depending on the mass the star had, the result can be several things. The first result could be a white dwarf if the star didn't really have much mass. The second result can be a neutron star if it has really much mass, and if it just has a little bit more mass, the star can result into a black hole, which has such a strong gravity that not even light can escape the gravitational force of the black hole. And this is actually why black holes are black, because light cannot escape black holes. Light cannot escape the event horizon of a black hole. And this is why black holes are black, because light cannot escape the gravity of the black hole. And this is fascinating. Light is something so fast and something, well, light rays, black holes can attract light rays. And this is, I think it's fascinating. Yes, but let's talk about neutron stars. Neutron stars emerge when a star collapses, which is not heavy enough to become a black hole. And a neutron star has almost such a strong gravity as a black hole has, and therefore the pressure in the inner core of the neutron star is really high. And that's why in the inner core of the neutron star there exists something which is called nuclear pasta, and this nuclear pasta is thought of as one of the densest materials in the universe. So, because of the high pressure in neutron stars, nuclear pasta has a really insanely high density. And one thing I've once read is that if you take 1 teaspoon of nuclear pasta, this teaspoon will have as much mass, will be as heavy as the Mount Everest and all the mountains around of it. So 1 teaspoon of nuclear pasta has more mass than the highest mountain on Earth. This is nuclear pasta, and this is how extreme space can be. So this is in neutron stars, atoms don't have their usual forms anymore. In neutron stars, the electrons are pushed into the core of the atoms, so the electrons are pushed onto the protons and they form neutrons. This is called Epsilon Decay, so electrons and protons together form neutrons. That's why it's called neutron stars, because there aren't any protons and no electrons anymore, because they are pushed into each other by the pressure and by the gravity, and the results are neutrons. And this is what neutron stars are. Also, many heavy elements like silver and gold and so on, they come from neutron stars, because actually the universe wouldn't have any motivation to do such heavy particles and such complex particles like gold if there wouldn't be things like neutron stars. So the only reason for heavy particles to exist, or one of the only reasons, is the pressure inside of neutron stars, which is the reason for these particles to exist actually. So if you are just looking into your computer consists of a small percentage of gold. So without the high pressure in neutron stars, your computer wouldn't even exist, because all the heavy elements we need for our life wouldn't exist without neutron stars. Or for example, carbon, which is the basis for our human life. Carbon is also synthesized in the sun, because the pressure in the sun is high enough to fuse carbon, or to fuse some smaller atoms to form carbon. So all these astronomy facts make our life actually possible. And this is something else I find really, really fascinating about this subject.
Another very interesting issue is time travel, and if you want to know more about that, just click here for part 3.